Okay, so welcome everybody. Um, this is my first real go around here at uh, creating a screencast and going through a PowerPoint as a lecture for all of you at home. So hopefully they'll get better as we go along. As I mentioned earlier, for all of you in AP, we're very close to the end of our content, and then just preparing for the AP exam. So I did want to go through the last part of the Chapter 18 PowerPoint so that you can view it and use the notes that you already have. I know maybe not all of you got back to school to pick up your materials, but um, this PowerPoint presentation will be posted on Schoology as well, so you can get it there without my lovely voice annotating it for you. Okay, so I might break this up into a couple of videos to finish up this PowerPoint. I don't want to have too big of a file, and then I don't know if it's going to be able to share, and you'll be able to open it and things like that. So as I go along, I'm going to post, what slide and in order, so that you can take a look at it. Okay. So I know some of you, in I think maybe period 2, Monday, Wednesday, we got through a little bit of this already. We got through like the first 2 pages, but I'm going to continue on as if we had not finished it up yet, or you haven't heard it yet, actually. Okay, so I'm going to try not to read, just read you the PowerPoint, because I know you can do that. I'm going to try to add some things as we go through. If you want to write those things down or listen to this a couple of times, you could. But remember what we're doing here in electrochemistry. We are using a chemical reaction to produce a current, that flow of electrons. So, and what we're able to do, as you can see there on the right-hand side of this slide, is separate the two halves of a redox reaction, one being the reduction and one being the oxidation, separating those two halves and allowing the electrons to flow through an external wire. This is called a galvanic cell, after Luigi Galvani, or a voltaic cell after Alessandro Volta, who both were developing in the 1800s these types of cells. And a group of these cells, as you can see, is called a battery. So this is more of a close-up view of what's going on in one of these galvanic cells. Okay, this specifically is a zinc and copper cell. You can see on the left-hand side, you have a zinc piece of metal, and that is submerged in a zinc solution. And you have in one half of the cell a copper piece of metal submerged in a copper solution. Those two are connected by an external wire that's attached to a voltmeter. And there also is in here, as you can see, a salt bridge. This can be, like you see right in front of you, a U-tube that is filled with a soluble salt that minimizes mixing of the two solutions. It can also be, if you go back and look at the last picture that you saw in the last slide, it can be a porous disc that allows the ions to flow from one side to another. So what's going on in this cell? So we have a spontaneous redox reaction, and electrons are traveling from the anode to the cathode. So in this case, it's from the left-hand side to the right-hand side. At the anode, as you can see here, what is actually happening there is those electrons are leaving, they're being transferred, and zinc metal is going into zinc solution, which is making that zinc solution more concentrated with zinc ions. What's actually happening to the zinc anode, or the zinc electrode, is it's losing mass. Those zinc atoms are actually going into solution. And the equations that is happening in that is right down here. On the right-hand side, you have your copper cell. And what's happening there? It is gaining electrons, okay? The cell equation is right down here. So what's actually happening is copper in the solution is gaining those two electrons, and it's plating out on the outside of the cathode. So in terms of mass, the copper cathode is actually gaining mass, and the copper solution is getting less concentrated in copper ions. So what the salt bridge does, if we can kind of get back to that, is it sends ions that migrate toward the side where it needs to overcome the either negative charge or positive charge. So in this case, since the copper solution is losing copper ions, the potassium ions migrate toward there to keep the solution neutral. Because in the zinc side, you're getting extra zinc ions with a +2 charge, the chloride ions are migrating towards that side in order to keep that side neutral. Okay. A couple other things just in terms of terminology. At the anode, that's where oxidation is taking place. And I always sort of remember that with anox. And at the on the copper side, at the cathode, that's where reduction is taking place. And I always remember that with red cat. So you can think of anox and red cat. Also, by convention, the anode's usually labeled the negative side or the black side, and the cathode is always labeled the positive side or the red side.